Hello, I'm Armin. Today we are going to talk about diaphragm forces, or more precisely, the lateral earthquake forces calculated by the software, and how these forces are applied to diaphragm and other elements outside of the diaphragm. And we will see how to visualize these forces graphically inside the program and understand how the software distributes the calculated seismic loads. The software can compute earthquake forces in two ways, either by using the predefined design code within the software, where we can modify the parameters based on our project, and ETABS will automatically calculate the lateral forces, or by using the user coefficient method, meaning we manually input the earthquake coefficients and the software distribute the lateral forces among the building story accordingly. For the 2800 code in Iran, we used this user coefficient based approach. So we've already defined C and K for this project, and now the program can calculate the earthquake forces for each story. If we want to check these forces and extract them from the program, for example, to evaluate overturning moments, one way is to graphically review the diaphragm forces. To do this, first we need to select all failures object. Go to Select menu, Object Type Failures, then from the Assign menu, choose Shell Diaphragms. Now we must to assign a rigid diaphragm to the floors. The program already has one predefined D1, so we assign that. If I switch to a 3D view, you can see that the diaphragm has been assigned to all the floor levels. For the program to perform the analysis, we need to run it, so it can calculate the forces based on the coefficients we applied. Once the run is complete, go to the display menu. Under Load Assign, select Joint Loads. There's also a shortcut on the toolbar that does the same thing. I will pick one of the seismic load cases, for example, the X direction load without accidental eccentricity, and apply it. Here we can now see the diaphragm forces as well as forces outside of the diaphragm. If I switch to a plan view, you will notice it's easier to interpret the forces. What we are seeing is a lateral load applied at the center of mass of each diaphragm. The forces on the members outside the diaphragm are applied directly to their corresponding joints. Their magnitude are much smaller compared to the total diaphragm load. Let me change the unit to ton meter so we can see them more clearly. The magnitude here is about 9024 tons, and these smaller values like 1.79 tons are relatively negligible. The largest value is roughly what we see here. However, if we want to compute the storage share, we need to sum all these forces together. The total represents the storage share at that level. In this case, the roof story. I hope you find this useful. If you have any question, feel free to ask in the comments. Thanks.